Welcome. So we are so happy that you're here. We hope that you're here for the Teaching with Tinkercad webinar series. Even if you're not, stay, join us. It's going to be fun. So my name is Carolyn Nguyen. We will do formal introductions in a moment, but when we start our formal program. But for now, we thought we would start with this fun kind of quiz question. So you have three options on the screen. So tonight we're going to be talking about advanced manufacturing and fun careers in advanced manufacturing. Which involves additive manufacturing or 3D printing. So we thought that this could be a fun quiz to start with, and we're asking you to look at these three model tops and decide which one, so A, B, or C, would be the most printable or the easiest to print without support material. You should also choose which would be the least 3D printable. So please let us know in the chat. Also feel free to say hi. Share where you're coming from. We have a teacher community that spans the global planet of Earth. So we're so excited that you're all here with us tonight for the Teaching with Tinkercad webinar series. So we're going to start with the warm-up, and we are asking you which of these model tops would be the most printable. So you're going to choose A, B, or C, and say most. And then you're going to choose which would be the least printable. So say least and choose A, B, or C. You might also share your reasoning in the chat as well. And we are also joined by Elena tonight, who is our chat vocalist, who's going to be sharing all of your responses and all of your inspiring ideas so that we can hear them too. So Elena, any ideas, any winners for the most printable so far?
Across the board. So we've got a lot of C's are coming up as least, but I just saw a C as a most. So I think it's we have a divided crowd. For sure, there's no clear winner. And so if anything, I think this talk tonight is going to be really great for determining a consensus at the end of the day. But thanks for having me tonight.
Has anyone shared their reasoning yet, Elena?
No, here we go. We've got one that says it depends on the printer, but C is the least. Oh, they're gone. Sorry, chat's too fast.
Well, you're lighting it up, and that's perfect because that's what we want you to do this evening.
There we go.
So we will take another minute or so.
I see B has the least slope, just came in.
Which one has the least slope?
B has the least slope is what someone wrote. C would need the least amount of supports. B has the least overhang.
Learning all types of new vocabulary as well, which perhaps we'll define later.
B has the least, so I'm not sure. There we go. So least C, most B.
I love seeing people talking about different print technologies and looking at different orientations. So we've definitely got some experts in here.
We have some experts on the panel tonight. There are quite a few 3D printers, 3D printer people who are going to be joining us tonight too.
A great question saying, does it depend on if it's a concavity or convexity? Some mentions about a 45-degree angle, which is foreshadowing.
Some advanced vocabulary here as well. All right, maybe we shall get started with the formal program and we'll continue this conversation around 3D printing. But to begin, welcome to the Teaching with Tinkercad webinar series. We're so happy that you chose to join us this evening or this afternoon or this morning, depending on where you are on Earth. Our topic for this evening is exploring advanced manufacturing for CTE month. And I put a little asterisk there to remind me to define what CTE month is for those who may not know. So CTE month is Career and Technical Education Month. And for this episode, we're going to be learning from some experts in the fields of not just advanced manufacturing, but some of the other industries that Autodesk supports. And we're going to be thinking about how we can tie that all together and thinking about how we can create pathways into some of these industries for our youngest innovators. So before we begin, I just wanted to introduce myself quickly. My name is Carolyn Nguyen. I am a youth program specialist at Autodesk. I was also a teacher in the Boston Public Schools for 13 years. Prior to joining Autodesk, I taught middle school English. Also am a national board certified teacher. My certification is not expired yet. And I also wanted to introduce you to our chat vocalist for this evening, Elena. Elena, you want to say hi and tell us a little bit about yourself?
Yeah, hi everyone. Thanks for having me, Kellyanne. So I'm a visual designer. I work at Autodesk in the K through 12 space. I'm also passionate about learning and always excited to jump on or bandwagon onto any of these webinars or high touch points with educators. And yes, so today I will be your chat vocalist. You'll see me kind of dropping any links if you have any questions that I can answer, I'll try there. But just a reminder, the Q&A is going to be the best place if you've got more technical questions, and chat will be more of a place for us just to kind of play and have some conversation while the presenters are going.
Thank you, Elena. You're such a talented chat vocalist. I can't wait to hear the rest of your chatting. If you want to chat with
ready for my evaluation at the end.
If you want to chat with us, we do have Twitter, we have Instagram, we do have TikTok now too, because we're really cool at Autodesk and Tinkercad and Instructable. So you can see all of the handles to connect with us. We also use the hashtag Tinker Together. So please, we want to keep this a two-way, three-way, 265-way conversation. So keep chatting it up in the chat, introduce yourselves to each other. And also do feel free to connect with us on social media. I am so delighted to introduce our panel of expert guests tonight for this topic. First off is Carolyn Nguyen. She has a master's degree in design from Berkeley. She's also a product designer. She currently works at Intuit, but she was also a manufacturing engineer. She designed and made rocket thrusters for traveling into space. So we're going to hear more from Carolyn tonight. And she's also going to talk to us about 3D printing. We are also joined by Dr. Fope Bademosi, who is a circular economy and construction researcher at Autodesk. So she's actually on the Autodesk research team. And if you want to learn more about the Autodesk research team and connect with Autodesk in that way, that's the handle for Twitter. And her teammate on the Autodesk research team is Kevin Acker. Kevin is a senior research engineer at Autodesk. So we're going to hear from all three of our guests tonight as we think about lighting pathways, particularly into advanced manufacturing for students. How to participate? You already know, you're already doing it. So we see a lot of reactions. We see people chatting and getting to know each other. Throughout this episode tonight, we'll be pushing out questions to kind of engage you in conversations with each other. You will see, I think we're all Zoom pros at this point, but at the bottom of your screen, there are 3 icons. As Elena had noted earlier, the best way to chat with each other and to learn from other teachers in the Tinkercad educator community is to just use the chat feature. However, if you have an advanced technical question or some question that you want specifically answered by someone on the Tinkercad team, please use the question and answer tool for that. And we have plenty of fine folks from the Tinkercad extended family behind their keys waiting to answer your questions. So there are real people who know about Tinkercad and other things who are going to be answering your questions.
And I just want to make a note there that if you are sending a chat, just make sure that you switch it over to everyone if you'd like it to be visible. I see a few that are making connections, but they're only coming to the host and panelists. So you can just switch it over to everyone if you'd like to share with some other people on the call.
Thank you, Elena. Such a great chat vocalist. So we do have some goals, and these are kind of goals for the whole series. So this is episode 2. So if you're just joining us now, don't worry about it. We recorded a last episode, and we'll share how you can access that later. But our goals are kind of consistent across the whole series. Tonight, we're going to be learning, so thinking about interdisciplinary learning. We're going to be hearing from, real STEM professionals who actually have to work in a cross-disciplinary way. And they're going to talk about how, they do that together in real life. We're going to be thinking about how we can create multiple on-ramps for students to learn STEM skills by making things that matter to them. One of the things that I think in terms of thinking about introducing new careers, which is our topic for this evening to students, a lot of times it's about stories. So we made sure that we left room tonight in our presentations for our presenters to talk about their stories and how they got into STEM careers. We are definitely going to apply knowledge of emerging trends. You're going to be blown away by some of the cool projects that our guests have worked on or are currently working on. We're going to think about how you might move students from Tinkercad to Fusion 360 when they're ready. And we're also going to be thinking about just some of the possibilities of what students could do as they advance from Tinkercad into Fusion 360. And of course, you'll always have the opportunity now throughout the webinar, and at the end, we'll have a question and answer to ask questions to the Tinkercad team. Just the schedule for upcoming episodes. So Thursday, March 23rd, we're going to be thinking about the topic of developing a product mindset with Tinkercad. So thinking about how you can go from prototype to product. And then we're going to be doing another episode in April and another in May. So please do stick around. If you're registered for this webinar, you're registered for the whole series. So our flow or our agenda for this evening, it's a little robotic tonight. So for number one, the first segment, we're going to be learning about 3D printing with Tinkercad, and Carolyn is going to be leading that discussion. Segment number two, we're going to be talking about design and the future of work and thinking about how you can make connections between Tinkercad, Fusion 360, Instructables, and how you can use those tools as a way to light those pathways. Number three, we're going to be hearing from Fope, and she's going to talk about a really cool project that she worked on at our Autodesk Technology Center in Boston around building bridges, both metaphorically and literally. Our fourth segment will be led by Kevin, and he's going to talk about next generation design for manufacturing, which is what he does every day. And last but not least, please do stick around at the end so we can do kind of a question and answer. So please, continue to ask questions, specific questions in the question and answer, and some of those questions might pop up again at the end. Before we begin, I think that Elena wants to issue a poll to take a pulse of the room. So the poll for this evening is, what grade level do you teach? So Elena, take it away.
Perfect. So everybody should be, there we go, seeing the poll, and we're going to start to see some results rolling in. All right, the early lead is grades 6 to 8 right now, closely followed though by a tie on 9 to 12 and 3 to 5.
Kind of like a horse race watching it.
It's very exciting.
So we're seeing a lot of middle school, huh?
Yeah, I'd say a lot of middle school, 6 to 8, and then we've got kind of a three-way tie on 9 to 12, 3 to 5, and then multiple or all ages.
K to gray. All right, so perhaps we'll end the poll soon.
Sounds great. And then would you like me to share the results with you?
Sure, I think it would be fun for people to see the results, so you know who's in the room with you.
Yeah, the winner with about 30%. Is middle school.
Nice. All right. Thank you for participating in our poll. I'm going to close this and move on. All right. So for our first segment, we are going to be talking about 3D printing with Tinkercad, and we are going to end the suspense about what the correct answers were to the warm-up question. So Carolyn, take it away.
Yeah, thank you, Kellyanne. And I'll start sharing my screen here.
You have the power, Carolyn.
Yeah, one panelist can share at a time. I'm trying to share my screen. Okay, got it. Continue. All right, and okay,
you did it, Carolyn.
You can see my screen?
Yes, we can.
Yay, technology. Okay, cool. All right.
Just so you know, Carolyn, we can see your entire screen, including your desktop, just in case there's anything.
Yeah, this is like,
there we go.
It is kind of
There we go.
Right
Now we
here.
just see your presentation.
Awesome. Yeah, so a little bit about myself. I started out, well, I grew up in Boston, in Dorchester, and I used to be Kellyanne's 7th grade homeroom student. And we've come a long way here. But I also went to Boston University to get my undergraduate degree in mechanical engineering and concentrated in manufacturing, because I was fascinated with like the show, how it's made, and like problem solving and stuff like that. So upon graduation, I was on my engineering path and I started working for Pratt & Whitney to prepare their engines. So if you're ever on an airplane and you open up that pamphlet and you see like PW2000 or 4000 or even GTF, those are the engines that I would repair. And that is kind of considered like old aerospace. So eventually over time, I started working at Blue Origin, where it's located in Seattle. And in this picture here, you can see that this is a mock-up of the engine that I worked on, which is BE7. And I show this today because BE7 is primarily a 3D printed engine. And so the great thing about 3D printing is that you can also build things very, very fast and have live mock-ups. And I realized as a manufacturing engineer that I always liked talking to the technicians, and like I was an assembly engineer. So all of the people, I always want human interaction. So I discovered that design gets me closer to the people. So I went to UC Berkeley, recently graduated, and now I work at Intuit, which is a whole different field, working on AI and data. But I always take problem solving with me.
Carolyn, you got to help me with my taxes soon.
Yeah, I'll have to also learn that too. But yeah, 3D printing in aerospace is huge, mostly because of like rotating parts. Like their hardware in aerospace tends to take a long time to create and make, and they're very intricate. So it's very costly and timely. So 3D printing allows us to rapidly prototype, and you cut out like a lot of machining processes and stuff. And you can even combine parts together where machines can't really like dig into. And the good thing about that is before you even go to the metal part, you can print it out in plastic and then try to assemble it all together like a Lego piece. And that's the beauty of 3D printing in aerospace. And it looks like from the chat, some people are already pretty expert. So I apologize if this is definitely not new to you, but for those of us that are still new, like when we're starting to 3D print, sometimes we have to start off with an adhesion layer. So one of the first ones is either a skirt, which means that you're still building on like the glass panel directly, but the skirt primarily just kind of like primes the beginning stages of your material before they start building your part. A brim is kind of like, think of like a brim of a hat. It's about like a layer or so, so that as you're printing your part, it doesn't start lifting, because we're working with plastic and over time it'll cool and it will either warp or lift or something. So just to keep it grounded. And a raft is a little bit heftier, and it's to keep your part like supported and keep it grounded. So for parts that need a little bit more support than brims for sure. And so again, a lot of you already know about overhangs. In 3D printing, we don't really like overhangs because it'll mess up our prints and support. And usually to support these overhangs, we need support material, which is like the waste material that has to either be dissolved or like cut off at the time. And overhangs tend to happen a lot when there are like anything more than 45-degree angles. So for example, down here, you see like the letter T, where there's like, if you think about like say Jenga or like putting layers of bricks on each other, right? Like you can't just go from a pillar and then automatically go like horizontally. And so that's why some of you had already referenced that if you turn it upside down or you find an orientation where it's always stable, then you might be able to print without support material. And through experimentation, they found that 45 degrees away from your vertical is kind of like the magic number. So as long as you kind of like stay within 45 degrees, you should be fine. Sometimes some parts have like these lips that kind of print into nowhere. So this would also require support material. So the way I try to explain it is like, think about building with bricks and Jenga. So it all depends on like cooling, how fast you're building and stuff like that. Other things to keep in mind are bridges. Like bridges are also kind of printed in air or use support material, but bridges have like these endpoints. Looks like some people have their hands raised. I think you can probably put your question in the Q&A so that people can answer it for now. But with bridges, like there is a certain distance where you should be able to print it without support material, but other times if it gets too heavy, it'll start drooping. And then there's also infill. So infill is like how dense your printed part is. And it's really cool. I mean, some of these patterns I probably have never seen in my own real life, but these different kinds of infill patterns, it can also represent like how your part will move, and like it kind of represents the material properties. Like if you're cutting through wood, you can see like the grain direction and stuff like that. So with something like this spiral right here, if you print it out, your part might be like, you can torque it, or like you can like turn it and stuff. Whereas others that are like honeycomb shaped, then they're pretty strong when you press down on it and like from different sides. So just something to think about when you're trying to optimize your prints. So I'm going to try to go through a live sorting activity just to kind of put into application what we talked about. So I just hope that my mouse will cooperate with me because I forgot to bring a mouse pad, but.
And we're also sharing the link out to the teacher, Mr. Garapi, who created this awesome sort back in September when we noticed it, and it was awesome.
Yeah, so for anyone who's following, if you're still figuring out how to navigate with the mouse, I use the right button to kind of like go and look at different angles, and then I use the middle button to kind of like pan. So sorting out the easy stuff first, usually anything with 90-degree angles, that's probably going to need support material. So I'm just going to start picking those out. These would all need like support material. This one for sure. What else in here? Oh, this one.
Yeah. That one's like my favorite, Carolyn. That's super innovative.
Yeah, it definitely needs support material, and then you'd end up with like two pieces. And so this one, it's like these corners and like radii, or like that's definitely just gonna need support material for sure. This one, this like bottom, I guess like layer is just really thin compared to everything else. So
it's nice tapering, though.
Yeah, it definitely needs like an adhesion plate or a raft. And then so on the other end, we're going to take a look at like what would be easy to print.
And we have a link to the answers as well. That's in the notes.
And I think that like there are some that kind of fall into the middle. Like you probably can change the parameters of the print program so that you try to figure out how to print it without like support material. So for these, like they have tapers, and like this one, it is more than 45 degrees, but like this is probably going to be fine if as you're slicing it, you can control like the infill and like how much cooling you want in there. So that one seems pretty safe. This one is also pretty safe. So I think everything else, these are just like, oh, my mouse is going crazy. Yeah, so all right, let me just.
And I'm just going to share the link so it's just the link in that in the notes, correct, Kellyanne?
Yeah, so there's two. So there's one with the activity, and then there's one with the answers. So it's all sorted.
Perfect.
Ahead of where Carolyn is right now.
Yeah, so these are like, could be fine. Like they do have more than 45 degrees, but you could probably finagle with that. eventually, like if you're playing Jenga and trying to build this, like eventually it's probably gonna fall apart. This one, like it looks a little bit imbalanced. You could try to keep playing around with it and stuff. So
Yeah, I
this
wonder
one,
if you could also, some of them, like if you did something at the top, could you like flip it and
yeah. So if you flip it, like of course all these are pointed, but if you put like a flat on there, you probably will be fine. And so let's see, this one is also kind of questionable. Where did it go? Yeah, so I think like some of these can kind of teeter between the two.
yeah, and I noticed actually in the chat, someone said that your answers might not be the same as the answers. I think some of this is like left up to debate as well.
Yeah, like
Because our answers design was from our 3D printer, 3D print shop manager in Boston. So some of these are debatable, which kind of makes the activity fun.
yeah, they really are. And like I would probably take it up as a challenge to like try to print them without support material, and you will probably find like a program that's like okay. And so with that, I'm just going to get to like our warm-up question and take a look at like the 3 parts that we had in the beginning, which is okay, so how did we do? So for those who said B is the easiest, that is correct because as you can see, it slowly tapers up and then there's like enough support to taper it back up. And then A is like, it's probably doable, not too bad. And then C, because of this 90-degree angle right here, it's gonna need support material. So yeah, it's definitely debatable. And I think even the person who created this sort filter, like he definitely mentioned there's a lot of debate going on. And so we'll end this section with like, what are some of your favorite fabrication tools or materials to teach with?
And one of the inspirations for this question, I just feel like that the student has become the teacher. Thank you, Carolyn, for teaching us some of your tips and pointers for 3D printing. Typically with Tinkercad, we're talking about design and not so much 3D printing. And some people are asking us, what's the best 3D printer? And we think we love all 3D printers equally. So we don't always typically talk about 3D printing, but in one of our previous webinars, teachers had said that they were really interested in learning more about 3D printing, but there are other ways of making things as well. So what are some of your favorite fabrication tools or materials to teach with? Like, what are some things that you like to use to make things with, Carolyn?
I think as a mechanical engineer, like the marshmallow challenge, it's like a good truss exercise where you learn how to like build bridges and like use marshmallows and spaghetti, non-cooked spaghetti, to build these weak but sturdy trusses. So I like that, and like Play-Doh.
You could do gumdrops with that too, right?
Gumdrops for sure. I've actually experimented in my design program using sugar as a way of like, I discovered that sugar can be like a sustainable material for, say, resin. So if you look up 3D printing sugar, there's definitely a formal way of 3D printing sugar and chocolate. And I figured out you can DIY that at home as well.
Well, PLA, I think, is made from like corn, right? It's like recycle. I bet Fope knows more about that, but
I'll leave that up to the expert. Yeah.
Yeah, it's meant to be a sustainable material, the PLA plastic that people typically print with. But I'm sure there's all types of good ideas in the chat. Prototyping was something that we talked about in our last episode. Anything else, Elena?
Yeah, we've got Legos and paper roller coasters, straws, cardboard. Something that came in before this question came up, which I thought was really interesting during your chat, Carolyn. And someone said they wished there was a dissolvable support material that existed. So
there are. I will also leave that to the expert to share some dissolvable support materials.
Right, but yeah, lots of micro bits and crickets, wonderful to see a lot of things. Acetone is in there. Oh, I'm assuming acetone is to help with the dissolving.
Awesome. Well, thank you for chatting it up with us. And thank you, Carolyn, for teaching us all the things about 3D printing. And we're going to move on just to talk a little bit about design and the future of work. So I think I've mentioned this before, but Tinkercad and Instructables are all part of the Autodesk family and Fusion 360 as well. At Autodesk, we empower innovators with design and make technology to achieve the new possible. And when we think about this, and we think about it even in the context of education, like who are our youngest innovators? And we want to learn more about them and what their motivations are in order to be able to design pathways for them into these awesome careers, like what Carolyn's doing now. And one of the things that we know about young people is that they're not necessarily people who are satisfied with the status quo. So they ask a lot of questions. So rather than just accepting what is, they ask what if. They also ask questions about like, how can I innovate to design and make a better world? When we say that word innovate, there's all different ways of defining it, but it really just means, adding value, improving the status quo, and they want to make progress now. They don't want to wait for the world to get better. They want to get hands-on now, even at young ages, in order to make improvements. When we say design and make, we're thinking about kind of within the context of Autodesk, there are sort of three kind of buckets or categories. So there's design for manufacturing and assembly. We also make tools for architects, engineers, people who work in construction, and also media and entertainment. And as adults, we oftentimes think of these as like three different buckets. But one of the things that we know about young people is that they see the connections and the convergence across these industries. So when Fope talks later about the convergence between design and manufacturing and construction, for them, it's kind of like second nature, but for us, it's like, oh, that's a novel idea. So young people are connectors. I'm sure you know that in the students that you're teaching today. They also, another thing that's second nature to them is collaboration. They know that there are a lot of kind of tricky problems to solve or big, tough problems to solve in the world. And they understand that in order to unlock solutions to some of those problems, it requires a diversity of perspectives. And that's actually one of the problems right now in a lot of the industries that we support, is that diversity isn't necessarily there. So that's another goal that we have around our learning instructional resources that we share. We also know that students and young people are curious doers. So what we mean by that is that they see learning as an iterative process. They like to get hands-on. They learn through making things and vice versa. They think of problems as opportunities. And we also know that they're caring. So they care about issues, kind of similar to some of our customers as well, around environmental sustainability, making awesome things and making sure that they are equitable and that everyone has access to them. So one of the ways that we try to help young people unlock solutions, and also their teachers too, is by providing tools that they can use for free as part of our education community. So Autodesk offers about 60 of its professional tools for free. So we all know that Tinkercad's free for everyone. These are free for teachers and students. And I think that we're sharing the link out to access some of these tools.
I've just dropped that in the link for anybody who's interested.
And then another thing that we do at Autodesk is we think about how we can be part of transforming manufacturing education. So this is another cool page, that talks about our collaboration with industry partners and universities around kind of identifying what are the new skills for Industry 4.0. So you see like technical, hard skills, soft skills, and also this emphasis on interdisciplinary skills. And then we break this down by roles. So then we talk about, like, for mechanical engineers, what skills are most important. For manufacturing engineers, it's a little different. And then when we think about a CNC machinist, for example, they're all different skills, kind of related, but different. So that's another link that we can share with you in the chat. And then when we think about, how to get started and where to begin, the foundation is, we think Tinkercad. So Tinkercad is free for everyone. It's easy to use, and it builds STEM confidence by introducing the foundational skills for innovation. Instructables is another offering. So once students turn 13, you as teachers can already access Autodesk Instructables because you are 13 or older, we're assuming, if you're teaching children. So this is step-by-step projects. It's a project sharing platform, and it's a community, just like Tinkercad is a community. And then when students turn 13, they can also access Fusion 360, which is kind of like a step up when students want to make designs that are a little bit more complex than what they can do in Tinkercad. So it's integrated CAD, CAM, CAE, and PCB, which is printed circuit boards. So they can get into circuits and as well. And that's recommended for high school and above. And they're also creating pathways. So your students might start out in Tinkercad. They might move on to Instructables once they turn 13 in order to find inspiration for project ideas. From Instructables, they might think, oh, I want to design something a little bit more complex, and they might move to Fusion 360. They might go straight from Tinkercad to Fusion 360, and they can do that in their browser as well with the Send to Fusion button. And students might start out in Fusion, but then want to go back to Instructables in order to find inspiration for projects. Another way that we try to engage with young people and help them think about the future and careers and the future of work is to think about how can I find purpose and make a difference through a career in manufacturing and or construction. So one of the ways that we did this last year is we created this film series with James Devlin, who is formerly of the New England Patriots. And he studied engineering. When he was in college, he studied mechanical engineering. And when he retired from the NFL, since then, he's been kind of putting on an entrepreneurial hat, and he wants to go back into kind of thinking about being an innovator in the built environment. So he took us through one of his real life projects that he was working on, which was a cafe that was housed in a shipping container. And then he introduced us to all the people that made it happen through telling their personal stories. So he talked with a carpenter, he talked with the landscape architect who made the really cool vertical garden. He spoke to the electrician who had to work within the unique constraints of a shipping container in order to power it up, and even talked to Fope as well. We also presented this to students as a challenge. So they were able to, we gave them a shipping container in Tinkercad, and we asked them to think about big issues like affordable housing and outdoor classrooms and COVID era public spaces. And we asked them to think about how they could use the shipping container in Tinkercad to imagine different worlds. And we did this through an Instructables contest as well. And you can see some of the entries that we received in the contest, where they went. So some students stayed in Tinkercad and did awesome designs in Tinkercad. Some students took the shipping container from Tinkercad and moved it into Revit, or moved it into Fusion 360, or moved it into AutoCAD. And you can see that their designs, they're not just thinking about their CAD skills or even their physical prototyping skills, but they're also thinking about important issues that they care about. For example, one student had a bike path in their community, but there was nothing, along it. So he thought to put a little like respite in the middle of the bike path for people to interact and engage with each other. Another student thought about how he could improve the lives of homeless people in Miami, where he lived. And another cool thing that they shared through their stories and Instructables is their process. So they showed you, they thought about the constructability of their designs and also how they could kind of invite you into their design process as well. So in 2022, through this program, we aimed to give away $100,000. So $50,000 was in scholarship awards and $50,000 was in micro grants. And the micro grants were $500, and they were for students, particularly going from high school into the building trades. And then the scholarship awards, the other $50,000 was through our contest that we hosted on Instructables, and we'll be hosting again in about a month. So we ended up actually only giving away $70,000. So we hope that this year we give away $100,000. So we need your help with that and spreading the word. But we were really excited that we were able to empower 84 young people on the path to construction careers. 57 of those recipients plan to enter the building trades directly from high school. And of those recipients, 45% attended school where the majority of students are people of color or come from low-income households. So this year, we're going to be doing it again. So I'm going to show you a sneak peek of our promotional video. and it's on the theme of building bridges. So that's where you can go to find out more information about the contest. But we are working with Connor Clifton of the Boston Bruins, who's a current player, and he's continuing, he's thinking about his journey post NHL with James Devlin of the Patriots. So again, the theme is building bridges. In about a minute, Fope is going to be talking about a literally cool bridge building project that she created at the Autodesk Technology Center in Boston. And it has all the things. So when you think about advanced manufacturing, it oftentimes includes additive manufacturing, so 3D printing. The materials that they use were environmentally sustainable. She used recycled polymers. They use generative design process in designing the bridge, which Kevin is going to talk about later. They used robotics, like Fope was literally programming the robot, which required computer programming as well. And also the bridge was embedded with sensors so that the bridge could, after it was built and installed, could continue to kind of provide information to the owners and to the users as well. And in all of this required interdisciplinary collaboration. So there's a lot of convergence in the story between, people who are manufacturing engineers, people who are designers, people who work in construction. So it's all the things, and just to reiterate, all those things are also in Tinkercad. So if you're overwhelmed by this idea of, all these new technologies that students need to learn, you can start with Tinkercad. So there's the 3D editor, there's the circuits editor, and the code blocks editor. All editors enable collaboration. We include starter projects. There's autosave. We care about teachers immensely, so we always kind of keep teachers in mind, and there are special teacher features, so teacher access to student work, for example. The 3D editor is where a lot of students begin, and even a lot of teachers begin, just by dragging and dropping shapes onto the work plane, combining them in order to make new, more complex shapes, subtracting from them. And you might 3D print them, or you could, export it as an image, or you could send it to a laser cutter, or even to a die cut machine to cut it out of cardboard. You can also send to Fusion 360. There's the circuits editor, so you can design anything from a simple circuit. You could program an Arduino. Microbit simulator is also within circuits. You can connect your board to a growing library of virtual components as well. And it allows you to test things. So you're not burning out your circuitry parts or your electronics in your classroom. You can do it on the computer first. And last but not least is the code blocks environment, which really allows students to think about how they can be creative through using STEM skills, and also that they can kind of think visually about coding. And one of the things about using code blocks in particular is you can just kind of really quickly, just from one shape, make a really complex design. And it's also teaching a process. So just like design is a process where you're iterating, coding is also a process as well. So you're stacking, you're running, you're review, you're repeating, and you're doing it over and over again, and you're learning from your mistakes. Tinkercad also sends to Fusion 360 in your browser. And we recently last year added a send to from circuits into Fusion 360 so that you can, when you're doing PCB design or printed circuit board design, you can continue tooling, simulating, routing, and milling. So before we move on to learning from Fope, we are wondering, which careers do your students seem most curious about? Anything, Elena?
The product design and industrial design.
Very cool.
We've got computer science, biomedical engineering, coding, circuits, video game design. I remember Well, that was a dream. I'm sure many of us had. Robotics and construction, aerospace, app design, game design. Yeah, a lot of video game design. I like that.
Right. Well, they're going to love Fope and Kevin's presentations, I think. So I'm going to step away from the mic and I'm going to pass it to Fope. Fope, feel free to steal the screen.
Thanks, Kellyanne. I think, do you see my presentation?
Yes.
Oh, perfect. Well, hello, everyone. My name is Fope Bademosi. I'm a researcher at Autodesk based in Boston. And tonight I'll be sharing with you my journey in construction and its intersection with advanced manufacturing. So I'm going to highlight some technology applications and job opportunities that, that intersection has created. So yeah, let's deep dive somewhat into this field. And I just wanted to say thank you again for joining us today. My mission in construction, if I'm to summarize it, really is to improve the world through technology and innovation. I believe that technology holds the key to solving a lot of the problems that we're facing with the environment and society. So I'm gonna just share my journey with you and how I came to this point. But my background is purely in construction, undergrad and graduate school, as well as my work in the industry so far. Oops. So just, to give you some context, I never thought that I'll end up in construction. I was really good at math and science, but I didn't know I wanted to study in college. But I did grow up with a father who's an architect. So I saw the opportunities that architecture offered, and I was, eager to follow in his footsteps. But life had different plans for me, and I found my passion for construction through unexpected opportunities. So when I was applying for undergrad, I was going for architecture, but I was placed by random selection into a construction management program, and I was given like a year to try it out. And, within that year, I quickly found that creativity wasn't really my strong suit, which is really needed for architecture. But I was more fascinated with the technical aspects of construction and realized that that was a better path for me. And after graduating from undergrad, I worked as an assistant project manager with the state government. I don't know if I mentioned, but I'm from Nigeria. I'm Nigerian. So I worked with the state government in the Ministry of Works and Transport, and that experience opened my eyes to a lot of the inadequacies in the construction ecosystem in sub-Saharan Africa and in developing regions, especially the lack of, affordable housing. So I enrolled in a master's in construction management to focus on sustainable housing solutions in Africa. But I got swayed with technology. So I took a class that introduced me to a lot of Autodesk products, really. So Revit and Navisworks and BIM 360 and all of that. And I was just enthralled by it all. So I became really interested in the use of advanced technologies in construction, so augmented reality, virtual reality. So I decided to, just do a PhD specializing in advanced construction technologies. And through this program, I was fortunate enough to intern with companies like White & Turner on the Star Wars and Toy Story rides in Disney World in Florida. And then I also did an internship with Autodesk with the Education Experiences team. And then upon graduation, I immediately went into academia, trying to, be an evangelist to the younger generation about these technologies and integrate that into construction management curriculum. So I did that for about 2 years, and I love teaching, but I missed the practical applications of these technologies in construction projects. So in January of 2022, I returned back to Autodesk as a construction researcher, kind of bringing my journey full circle, I believe. So I just wanted to take a moment to, explain the construction industry for some of us that might be unfamiliar with it. So the construction industry really is all-encompassing of the people and businesses that are involved rebuilding the world all around us, right? So there's about 170 at least professions that are involved in that, building everything from houses to stadiums. And the industry makes up about 7% of the world's workforce and, you know, generates about 13% of the global GDP. And the sector is, you know, growing and thriving. It's expected to reach $14 trillion by 2025, and we're constantly building things. So there's always going to be jobs in construction. But just like any other industry, you know, it's not without its own challenges. And with the pandemic and supply chain disruptions, rising costs and all of that, this has only, you know, increased these difficulties. But there's always going to be need for infrastructure and supporting networks, as well as, you know, housing. So like I said, there's always going to be work in construction, but there is a need for increased digitization and industrialization. And this is the key to overcoming most of these challenges that the industry is facing, right? So companies are beginning to incorporate technologies like digital sensors, robotics and automation, autonomous equipment, connected BIM, and similar software to streamline their construction projects. So that's how, you know, my career has been in industry, helping companies digitize their workflow. So I began my career as a building information modeling, which we call BIM, or a VDC specialist, using software like Revit to, you know, create 3D plans for projects. You can think of BIM models as adult Tinkercad models, right? So you can have it of different disciplines, architecture, or the MEP, mechanical engineering, plumbing, your HVAC system, and so on. And these models allow professionals to analyze every detail in a virtual environment before physical construction, so we can, you know, make corrections or improve decision-making during the design process before we break ground on site. And then I advanced to using reality capture technologies like drones, laser scanners, augmented reality and virtual reality to help capture the as-built conditions of real-world buildings or objects or sites, and helping to, you know, convert the data into models and visualization for design and construction purposes, for safety training and things like that. You can also incorporate this into your classroom. So in academia, I used it to bring job sites into the classroom to kind of expose students to everyday construction processes that, you know, might not be possible by going onto the site every day. So you can bring the site into your classrooms. And then most recently, I have, like Kellyanne said, been using large-scale industrial robots for construction as part of my job here at Autodesk. So when I joined, I was fortunate enough to join a talented team of engineers and roboticists, machinists, computer scientists, construction people, people with manufacturing background, just a wide extent of skills and knowledge. And we were on this project where we had to 3D print a 16-foot pedestrian bridge for a customer using a fully automated industrial robot. And the project aimed to really explore new workflows for creating civil infrastructure using manufacturing technologies and techniques. So the bridge is made out of recycled PETG, so which is really just recycled manufacturing waste, mixed with 30% glass fiber for reinforcement. At the end, it ended up weighing about 960 kilograms and, you know, supports about 2.5 tons of any load. The design used Fusion 360's generative design. And then we have a gyroid infill for added strength. The bridge, I'll show more pictures, was really printed at an upright position. So that's why I was seeing it at a 45-degree angle, but ended up being supported at both sides. It took about 200 hours over 5 weeks to print this, averaging about 10 hours every day. It was closely monitored by everyone on the team, physically at the Boston Tech Center. And then we also used sensors, so thermal cameras, temperature sensors to ensure that the material remained in the appropriate range. We had to be about 240 to 270 degrees Celsius. So here's just some more pictures showing you, more about the gyroid infill. And, we can see, and Kevin is going to talk some about generative design, but generative design and 3D printing do offer numerous benefits to construction, including, manufacturing customized parts that, can handle a lot of complex loads and forces. And because it's a computer, there's limited or limitless rather design potential that you usually would result in something futuristic or very intricate. Like, so most people have commented that the gyroid infill of the bridge reminds them of like a bone structure of human beings or animals. And here's a look at the final installation at Autodesk University last September. And if you're interested in learning more, I've included links to blog posts about the project that includes very detailed step-by-step processes of how we achieved this project. So what's the excitement about, advanced construction technologies? As mentioned, the industry faces several challenges, and but the major challenge that the industry faces is the shortage of skilled and experienced workers to meet the project demands. And we have increasing population, increased urbanization. So there's an increased demand, but we don't have the supply to meet that. So this shortage stems from factors like the aging workforce, low interest in construction careers, right? So people think construction is very laborious or tasking or boring, or it's mostly for guys. And there's also limited training programs and apprenticeships available to help encourage students. But technology is the best way the industry is going. We are addressing this labor shortage because it increases automation and digitization. So the future of construction is going to look something like this, where we have robots and 3D printing, VR, AR being implemented daily on site to help reduce manual labor, and enhance collaboration. Right, we're going to be seeing more prefabrication and modular construction, where things are produced off-site and assembled on-site. And then, as Kellyanne mentioned earlier, sustainability is also a big issue, and technology is also going to emphasize sustainability through the use of green technologies and materials, as we're starting to see now in the industry. Integrating these technologies has led to new jobs, right? So we have roles like robotics technicians, 3D printing specialists, prefabrication specialists, and so on, data analysis. So these are less typical construction jobs. So there's so much opportunity for anyone depending on their interest. And as the industry continues to grow, there's going to be new roles and opportunities likely to emerge as well, providing new career paths for students or younger people in the field. So to summarize, the industry needs a new diverse workforce, right? So integrating technology, converging advanced manufacturing reconstruction is the way to go about this, with creating new paths for people in the industry, making it more than just manual labor or more than just being on site and so on. So I would like to just encourage you to encourage your young students, particularly girls and underrepresented groups, to explore construction and advanced manufacturing as career options, as it's critical to meet the growing demand for skilled skilled laborers. And the industry's future is bright, and we have technology adoption increasing every day. So this is why we need new people to join this exciting field. That's it. Thank you.
Well, you're getting a lot of love, Fope. Dr. Fope. I think I want to be you when I grow up.
Yeah, that's all I have. Happy to answer questions at the end.
Awesome. All right, we're going to move back into our chat. So aside from being Fope when you grow up, which careers do your students seem most curious about? We did that question already, right? Or no, we didn't. Did we?
Yes.
Yes, we did. The next question is, which career most interested you when you were growing up? So which career most interested you? What did you want to be? What did you want to be when you grew up, Fope? You wanted to be an architect, right?
I initially wanted to be a doctor.
Okay.
Like a medical doctor, a pediatrician to be exact. But I told my mom I didn't want to go to school for 10 plus years.
I wanted to be an artist, Fope.
And then I wanted to be an architect. And then I ended up going to school for construction for 10 plus years anyway. So I should have just been a doctor of medicine.
Well, you're a doctor of construction. That's awesome. And you're also a drone pilot too. I have to throw that in.
Yes, I am. Your students can also take the drone pilot exam and become drone pilots.
So cool. All right, it is getting late, so we're going to move on to Kevin's presentation. And he's going to be talking about the exciting topic of next generation design for manufacturing. Thank you so much, Dr. Fope.
Perfect. And just a reminder to everybody that we will have this recorded. So if you do have to leave, they will be out. Kellyanne, do you email out the link to everyone, or how did they find it?
So by Monday or so, you should be getting an email with the link to the presentations. Because you're here live, sorry for those that are watching this on the recording in the future, but if you're here live, you get the certificate as well. So there will be a certificate that says that you stayed for the hour. So moving on to Kevin's presentation. Hello, Kevin. Kevin, if you're talking, we can't hear.
It would be helpful if I wasn't muted, right?
It's okay.
So all I was saying was hello to everyone who has joined us today. I appreciate your time and hope this has been interesting for you. So my name is Kevin Acker. I'm a senior research engineer on the manufacturing industry futures team within Autodesk Research. We're a multidisciplinary team of researchers, engineers, and industry specialists who really focus on cutting-edge design and manufacturing technologies. So I work out of our Boston Technology Center, and I've been with Autodesk for almost 3.5 years. I previously worked in the medical device industry, where I built a background in additive manufacturing and next-generation design. But how did I arrive at my position? Well, I grew up in northern New Jersey, loving Legos and doing so-called science experiments with the contents of my mom's kitchen cabinets. As I got into high school, I joined First Robotics and got really interested in engineering in general. So when it came time to choose a college, I decided to attend a school outside of New York City called Stevens Institute of Technology as a mechanical engineering major. I knew I wanted to be a mechanical engineer, but I didn't know what I wanted to do with it. So I enrolled in a co-op program, which meant that I would be in school for 5 years instead of 4, but I worked every other semester instead of going to school. So for my first co-op, I went to L'Oreal USA as a manufacturing engineering co-op, where I learned more than I thought I ever would about the manufacturing of makeup. My mom and sisters loved it so much that I returned again. But after my second L'Oreal co-op, I decided I wanted to be more involved in mechanical design, something I don't think I would have learned without my co-ops. This led me to interview with a medical device company called Stryker. I worked at Stryker 3 times as a co-op in a variety of roles. And this is where I found my true love, additive manufacturing or 3D printing. So for the first time, I could design something during the day, print it overnight, and have it in hand next morning. I loved the design freedom and being able to create parts that couldn't be made any other way. So I ended up joining Stryker full-time after graduating and became an additive manufacturing application engineer. In this role, it was my job to teach all of the company's divisions about the different 3D printing technologies and how to take advantage of them. I got to travel the United States into UK, Germany, and Ireland, and I loved my job. But in late 2019, I got the opportunity to interview with Autodesk to do a similar role, just across a number of different industries, which was really attractive to me. Only one issue, it was in Michigan. So I packed up and I moved to Metro Detroit in November of 2019. As we all know now, about 5 months after that, we were introduced to COVID and many things changed. As our work changed, so did the team's needs. And in September of 2020, I relocated to Boston, where we have an awesome technology center with 3D printers and robots. So I like to share and to demonstrate that my journey hasn't been a straight path to where I am today. I didn't see any of the next steps in my career journey until they were upon me. And I think it's really important we teach students not to stress about following a linear path, because each detour will provide them experience that's valuable later on. But enough about me. We're meant to be talking about next generation design tools, so I'll get back on topic. So what are the drivers for developing these design tools? Right? Like most engineers, I love looking at examples like the ones on the screen. They look cool, different, but why do we care? Why is it important for us to be able to create these structures? Well, in the last decade, additive manufacturing has been growing in popularity, but more importantly, growing in practicality. Traditional design tools are just limited in their utility for the various additive manufacturing methods. They're created to generate features for traditional manufacturing methods like injection molding, machining, casting, and we need new design capabilities to take advantage of our new advanced manufacturing methods. Borrowing this additive staircase from our friends at Renishaw, with the limitations of traditional CAD tools, we find many designers find themselves stuck on the prototyping and direct part replacement rungs of additive adoption. And they get frustrated because they're not seeing the value. What we want to enable through tools like generative design and Autodesk build simulation is to boost our customers to the top of the staircase, to get them to a place where they can create designs that deliver value across the product lifecycle. But what is this generative design that I'm talking about? Well, generative design is a multi-objective design exploration tool that helps you discover new ways to design parts with manufacturability, performance, and cost constraints, generating many permutations to help you find the design that best fits your application. Generative design mimics nature's evolutionary approach to design, with our goal being to maximize the performance of the component for a given set of loads, boundary conditions, and constraints. It's a whole lot of words, but what does it actually mean? As an example, let's take a look at how we would use generative design to redesign this bracket. To set up our generative study, we're going to first define preserve regions, shown here in green. These are features that my end design must include. In this case, all of the bolt holes are my preserve regions. Then we're going to define our obstacles. These are zones we don't want any material in. In this case, protecting access to insert the bolts into the bracket. And together, this is what our preserves and our obstacles look like. Then, since generative design is a physics-driven tool, we're going to define the loads on the bracket. In our demonstration here, I'm saying that there's a force being applied perpendicular to the faces shown. And we also need to define how our bracket is constrained. Here, I'm fixing the 4 cylindrical features so that they cannot move, simulating that it would be bolted down. We're almost ready to run our study, but I need to apply the material I want to consider for my bracket. I also need to input what my objective is. I'm choosing to minimize the mass while maintaining a factor of safety of 2. And then I select my manufacturing methods. You know I'm going with additive. So now that we've selected all of those, we can run our study and go get a cup of coffee. And ta-da! The generative solver then creates designs based on the constraints we apply. We can use filters and graphs to evaluate the solutions and choose the one that best fits our needs. Here's the design I chose. You can see it's very organic. It's a design that would have been very challenging for me to find on my own. So through our design and manufacturing tools like generative design, we want to enable our customers to blur the lines, to think about design and manufacturing together, remove that split between disciplines. We want to focus on shape freedom, design on the product limits, design based on the product limits, eschewing the traditional manufacturing constraints. We want to leverage the opportunity to combine the functions of multiple components into one. We want to use new design capabilities to generate products that meet the needs of the entire system. And we want to iterate, design, test, learn. With generative and additive manufacturing, you have the opportunity to perform design and test iterations quickly and at less cost, with no tooling timelines or iterative costs. And that iteration piece is important. If we look at the historic product development process, it's very linear. Concepts are evaluated in series, and it's very time-consuming. But if we contrast that with the generative design process, we're able to consolidate that iteration, those iterations, by evaluating multiple materials, multiple manufacturing methods, and multiple loading scenarios in parallel. And that provides us with a number of design iterations all at once. We can then plot those results by various metrics, providing the designer a way to evaluate performance at a glance and to narrow down to their preferred design. So what are some applications we've worked with customers on to demonstrate what these tools can do? Well, we worked with Honda to explore redesigning a crankshaft. Using generative design, we delivered an array of design options, unlike conventional topology optimization, which would provide only one solution. And that allowed the team to explore a number of scenarios. The design chosen was one that the Honda engineer said was a configuration I had not even considered. This new crankshaft design exceeded the goals by a surprising 50% weight reduction. And integrating manufacturing into the design process proved invaluable, with the Honda engineer quoted as saying, "It provides us with models that can take into account design limitations, such as those introduced by using additive manufacturing, mold-based manufacturing, or 5-axis machining." And here is that part after actually being manufactured. The second example I'd like to share is from work with Lightning Motorcycles, a company that designs and manufactures electric motorcycles. For the project, the team looked to redesign the rear swing arm, which is traditionally made of 3 parts bolted together. The assembly was chosen for its scale and to create a comparison to known materials using known manufacturing processes for a part developed by engineers. The team evaluated 5 primary load cases with a goal to reduce weight while maintaining a qualitative road feel. The generatively designed swing arm matched its original counterpart in 4 of the 5 load cases, with the 5th outperforming by as much as 55%. And key to consider is that Lightning was able to evaluate both additive manufacturing and casting for this component, exploring a new manufacturing method alongside one with thousands of years of history in the same run. So why do we need these next generation design tools? Why do we want to develop them? Because through the use of these tools, our customers can innovate. They can lightweight, they can reduce their material utilization. They can improve product performance and design. They can use physics-driven optimization of parts rather than being constrained by CAD, experience, or intuition. They can get new design inspiration and deeper insight into product performance, designing beyond their human bias. And we can expand the power of making by coupling new design tools and manufacturing processes, turning the digital into the physical representation in record time. Thank you.
That was so cool. And thinking about it, Kevin, that one actually resource, if like Nicole or someone in the chat could, there's an Instructable it's a random daisy generator Instructable that was made by MIT Edgerton. They have a really awesome collection of Instructables. And as you're talking, Kevin, some of the teachers were like, this is so awesome, but like I teach really little ones, and like, how can I make that connection now to kind of some of the possibilities of the future? And that's a really cool example, because the random daisy generator is already created in code blocks. They share the code with you, and all you're doing really is just noticing that they're using variables in order to make the design kind of more flexible, and you can play with it. And then there's the random block. So basically all you're doing is like plugging in, plug in the random block, and then every time you hit run, a new number of petals and kind of shapes come out of the design. So just in thinking about, how do I share this, or how do I convey this with students later? It's like you're showing them the possibilities, and then it's like Tinkercad and all of the cool things that you can do with it are kind of building blocks into seeing the possibilities of the future. So thank you for opening up that window for us, Kevin, because it was so interesting. What are some things that you might want to reimagine with the help of generative design? That is our chat question. Kevin, do you have ideas of something that you would want to do? Maybe it's like not in manufacturing, maybe it's like in some other realm of making.
Well, I'm a bit biased because of my med device background, and someone just said prosthetics. And I really identify with that. Different joint replacements, looking at generative solutions for people who have different bone cancers, or might have previously needed an amputation, but if we can design an implant for them to save the limb through generative design, things like that. So
cool.
It's where my mind goes to, and I saw someone else had that similar
Scoliosis braces is another one that I feel like is opportunity for innovation that a lot of our little ones suffer from. So we're going to keep it moving, just because we want to be mindful of your time, because it's getting late for some of our teaching friends that have to wake up early in the morning. We are going to push out one more poll. So how likely are you to use something that you learned in today's webinar? Seeing a lot of very likelies. This is awesome. And we know that we are presenting really kind of high level information to you, but we hope that we've done it in a way that you can kind of process it as expert teachers that you are, and think about how you can adapt it to your students. So thank you so much for participating in our poll.
Yeah, there was a really lovely comment. I think it's kind of gotten buried a little bit now with all of the chat responses, but it was saying that even if this is something outside of the skill level that you're teaching, that they're great examples of things that your students could grow into, and how they could see a career path, or what they could be creating in the real world with those skills that you're teaching them today. So I thought that was a really good response. I've lost your name, but thank you, whoever you were. Hope Loveland.
Thank you. You're now the chat captain.
Oh, I have graduated. Thank you.
All right. So I'm gonna stop. So just a couple more things before we move on to our question and answer is announcements. So the game design student design challenge, clocks contest, block code contest, and the Make It Glow contest are all still live on Instructables right now. And these are opportunities to also think about how you might use Fusion, or a combination of Tinkercad and Fusion, or just Tinkercad. So those are some fun contests. And we also just wanted to let you know about our next episode. So our next episode is, we're going to be thinking about going from prototype to product. We're also going to be sharing some interesting new things that you might see in Tinkercad in the future in our next episode as well. And we're going to be joined by Jem Stevenson. He's the founder of Fabright Origins, and he is also digital fabricator, and he teaches 3D design primarily to high school students and also to some college students as well. So please, we hope that you return for that episode. Ways to connect with us. So this is also linked in our slideshow. So please do stay connected with us. Your certificate will be coming for those who attended live. So you will be getting an email probably by Monday with the slides and the certificate. So I'm going to stop sharing my screen. And we are in our question and answer session. So I know that we've went a little long tonight. So if there are any questions, Elena, in the question and answer that went unanswered, or
looks like, let's see if any Q&A. So there was a question about the contest, if they are global, and on the contest page in the rules, they'll let you know which countries. It is global, but there are some countries that we cannot run contests in, but that's all in the in there. So let's see, is there an electronics equivalent for generative design? This was submitted by Nick Carter.
Kevin?
Yeah, so it's a great question. It's definitely something I've heard discussed, and people have looked at different similar solutions, but Autodesk doesn't have a generative electronics offering at this time.
This one, maybe Nicole, you might know, but are these competitions open to students in Australia?
I believe that Austria is included. It really just depends if there's like an embargo with the US and if we legally cannot run a contest in your country.
So here's a question from Peter. What is your favorite thing you've personally designed in Tinkercad? So I don't know, I'll punt this over to Kelly Ann. Let's see what your favorite Tinkercad design is.
Well, when I was first teaching myself Tinkercad, I was also managing a partnership with the Boston Bruins. And one of the things, we did a lot of like Stanley Cup, and then we did hockey pucks, like innovate the puck. But then we were thinking about, because they have a really cool team for people with limb differences, that they, particularly young people who play hockey, and they use hockey sleds. And I was like, I want to make a hockey sled in Tinkercad. And that was like my first like really challenging thing that I made in Tinkercad was I designed. And I just felt proud of myself. And I did like Frankenstein things. Like I found, I think like a sled in the gallery. And then I found a skate, like a figure skate or a hockey skate. It was like a figure skate, and added that to the bottom of it. But it was the first thing that I made that I felt like was really creative, and I felt proud to show it off.
Thanks for sharing, Kellyanne. This is a question for Kevin. So Paul was asking if you were doing the generative design in Fusion 360, or was this a more advanced Autodesk software?
Nope, so this is Fusion 360. And if you guys don't mind, I'll share my screen for a second just to show how you navigate to generative design. So do you see the Fusion window?
Yeah. So cool, Kevin. Thank you.
So here's the preserves and the obstacles for that part I was talking about during the presentation. And all I'm going to do is change my environment from the design environment to generative design. And now I can set up my study. So this is where I was assigning the loads and all of the constraints and stuff. And then I'm able to run it right from Fusion 360.
And generative is available as part of the education account as well. So students and teachers can play with it too.
There's a great question from Corey of when will I know when I'm ready to advance from Tinkercad to Fusion 360? And I think there might be a blog post that we have available for that, but if anybody,
I feel like Guillermo is the expert on that, and he did a webinar on it last year. So we do have a webinar recording. But there's a great blog post on that. But it's like, if your students are asking you questions like, I want to make this shape, more organic, or, I want to, cross section it so that I can see the inside, like chances are they might be ready to move on to Fusion from Tinkercad.
Great. Thanks, Kellyanne. Yeah, I was going to try to pull up that webinar for you, but if you go to Tinkercad's YouTube, you should be able to find that webinar link, correct?
Mm-hmm. Yep.
Great.
It's on the playlist. And when you get sent the recording, it's just the playlist. So you just got to go down a little bit. I think it's like level up from Tinkercad to Fusion 360. So that was a great episode. And Guillermo demonstrated a little bit around moving from Tinkercad to Fusion 360 using the Send to Fusion. And we also heard from an awesome maker, Nisha McCrae, who created kind of a series of little kind of mini projects that were around designing a helmet in Tinkercad, and then just various things that you could do to it to extend your design in Fusion 360, including applying physical materials and rendering. And I'm not the best at Fusion 360, I might be the worst, but one of the things I can do is applying physical materials and rendering, because it's just like coloring in 3D. You're just, dragging and dropping onto the surfaces, and it's artistic and fun.
Yeah, there's a great question. I think, Christian, you might have just answered it, but it was just about something that they love about Tinkercad is that you can use it as long as it's browser supported. You can use it on a variety of different computers. But if Fusion is accessible, I think through Chromebook, I think that was the question. And
yeah. Fusion has I believe it's for educational licenses, right? So you can run Fusion on a Chromebook, and it's basically you're running a remote version, a remote instance of Fusion right there through the Chromebook. Of course, you can install it for Mac or PC. It's available for download for those platforms.
And then this is one that I'm not. So does Autodesk have an app for making the trace design of a printed circuit starting from circuit created in Tinkercad circuits? Thanks. So this is a little bit outside of my understanding, but if anyone else.
Well, let me just give you the short answer. You can design circuits in Tinkercad and connect components, like encoders and sensors and things like that, or microcontrollers such as Arduino and microbits. You can do all of that stuff. You can send that from the Tinkercad circuits editor over to Fusion Electronics, and it comes across, into Fusion Electronics with those connections, and where you can take it even further to do sort of auto routing workflows that are related to printing or making a PCB. So I hope that helps.
Perfect. I think that wraps up.
And it's late. And one more question, Elena.
No, it's and this is just a PSA for anybody who's new to Tinkercad. So a question came in: is there any way to use Tinkercad offline? And I believe the answer is no, that it is browser supported currently, and so it is you do need to be online to use Tinkercad.
Correct.
The plus side of that, though, is that it doesn't matter what computer you're on, you can always take your designs with you and log in from anywhere.
I've seen people use Tinkercad on their phones, and I'm like, do not advise, but that's fascinating that you're doing that. So particularly the code blocks, you can sort of do. I've seen people do that, but yeah. Not the most fun Tinkercad experience. But we hope that this was a fun Tinkercad experience. Thank you for everyone for sticking around. I want to thank our guests. Carolyn had to step out. She's starting a new job this week. So we are so happy and grateful for her time. And also our awesome colleagues from the Autodesk research team, Fope and Kevin, for opening up a window into the future of making for us, and all of the teachers that joined us tonight from all over the world. We're so happy that you came, and we hope that you return and come back in March. We know it's in a few weeks from now, but there should be some really exciting stuff happening that we're really excited to show you too. So thank you again for joining us, and until next time, happy tinkering, and we're gonna say goodnight for the evening. All right, take care, everyone.